Hello everyone. We will continue our discussion on which type of market structure supports innovation. First, we will have a quick recap, particularly the diagrammatic representation that we have seen earlier. Here, I am sure by now you are well versed with where we are getting these numbers from, like the quantity that is to be supplied for K, K prime, etc. Like earlier, we say that the K is the cost before innovation and K prime is the cost of production after innovation. And the specific case that we are looking at is that of a process innovation. We have compared earlier monopoly and Bertrand competition. There we saw that for a monopolist, when they are making profit after innovating, that profit actually also eats into the profit they were making before the innovation come into picture. So here, if I look at this particular area where I am making these standing lines, this is a case of the profit which the monopolist was making before the process innovation, and the one with the horizontal lines is that of the after the innovation. Now you can see that this area where I am now putting this slanting lines is something which has reduced. On the other hand, this is the area which has increased. So for a monopolist, they have to make a comparison between these areas before making a final call in terms of whether to go ahead with the innovation or not. So clearly the distinction between these two also determines what are the incentive for a monopolist to innovate. On the other hand, when we are looking at a Bertrand competition, a duopoly situation whereby the price is equal to the marginal cost, we have seen that even in case of a non-drastic innovation, one of the competitor will continue with the price at K. However, if they innovate and reduce the cost of production, let us say from K to P prime, they will be able to enjoy profit, and that will be equal to the area determined by the decline in the cost from K to K prime and also the output that they will be selling at that point. So this comparison then we will do in a mathematical model now. So here we have considered a linear demand function. S is for the market side. We have received an inverse demand function from here where P is now being written equal to A minus Q by S. If you look at the objective that any monopolist would have, that is of a profit maximization with respect to the K, which would be your marginal cost of production. So then what a monopolist will do? They will write their profit equal to total revenue minus total cost, which will they find in given this particular circumstance being equal to A minus Q by S into Q minus K by Q. And they will maximize the same with respect to Q. We will get price equal to A plus K by 2. Using we can get the value of Q, and once we plug in these numbers to calculate your total revenue and total cost, you will find that the profit will be now equal to S by 4 into A minus K whole square. So then using this, we have to now figure out whether the monopolist will making profit or not if he or she go ahead with the innovation. Now in order to do that, what kind of a comparison we have to make? We have to now compare the profit which the monopolist will make if the cost is now K prime, which we have said earlier is the reduced cost of production because of the innovation, and compare it with the profit which he or she will make if the cost of production is now K. The difference between the two will highlight or will give us what would be the incentive of the monopolist to innovate. So if you do that, if you make this calculation, now in the earlier result here, if the cost of production is not k but k prime, again with the same demand function we should be able to get that the profit would be equal to s by 4 a minus k prime whole square. So then what are we going to do? We are going to subtract this term, which is based on the profit attained by the monopolist when the cost of production is k, from the equation or from the profit which the firm will get when your cost of production is k prime. So this is what we have done here, and after readjusting the terms, this is what you will get. Just to give you a brief idea, what we have written, s by 4 a minus k prime whole square minus s by 4 a minus k whole square. This is what we have done, and once we open this, clearly you can open these terms and then put them together, bring the common terms, and you should be able to get this s by 4 into 2a minus k prime minus k multiplied by k minus k prime. On the other hand, when we look at the profit which now will be made by Bertrand duopolist, or one of the a firm which has now come up with the process innovation, their profit calculation is rather very simple. How come? So you have this particular P which gives you, and which you get from your inverse demand function. Now in a competitive situation, you have marginal cost will equal to your price, so this you equate it to now k. Yes, then what would be your q in this case? You can find very clearly your q will be equal to s into a minus k. Now if I go back to that graph once again, what we have found in this case, that the Bertrand duopolist will not be able to reduce the price from P, which was equal to now k, right? But suppose this is what they are selling at that particular point, so this is the new k prime, so they will continue to sell the same amount, that is s into a minus k, and the difference in the k and k prime will determine their profit. So once you multiply that, you will be able to get the profit which will be made by the Bertrand competitor in a market. And in order to prove now our earlier point, where we have highlighted that the incentive under competition is rather large as compared to that of a monopoly, we have to now compare these two terms. Which two terms? The change in the profit for a monopolist when they engage in a process innovation, and the specific case of process innovation which we have taken is that of a non-drastic one, and the profit which will be made by a Bertrand competitor as compared to the other firm in the market when they once again reduce the price from k to k prime. Clearly it's very straightforward comparison. That means we have to compare this term coming from equation 3 to the term from equation 2, and in order to prove our point, we have to show that this is greater than the other side. Now how can we do that? So once again we engage with the terms on both sides. Clearly these two can be cancelled, s can also be very easily cancelled, so that we are left with a minus k on this side and 1 by 4 into 2a minus k prime by k on this side. This can be very easily written as a being greater than 2k minus k prime plus k by 2. Now we have to show that this situation will hold in order to once again prove that the profit that a Bertrand player will earn is going to be higher than the monopolist. So how are we going to do that? In order to do that, once again we go to the price which will be charged by a monopolist if the cost of production is now k prime. As we have seen earlier, here when your cost was equal to k, price was equal to a plus k by 2. As the cost reduces to k prime, clearly price will now be equal to a plus k prime by 2 for a monopolist. On the other hand, in the Bertrand competition, the firm will be charging P being equal to K, which is their marginal cost of production. Now this K being a marginal cost of production stands only for the non-innovating firm, whereas the innovating firm has K prime as their cost of production. Now, given the special circumstance of a non-drastic cost reduction, the way we have defined it earlier, very clearly we know that the price will be charged in this particular case by the monopolist is going to be higher than the marginal cost that exists before the innovation. So A plus K prime by 2 is now going to be greater than K. In case if you have a confusion, you can go back to the earlier lecture where we have discussed the definition of drastic versus non-drastic, and this will fall into place. Now, once we have this, that A plus K prime by 2 is going to be greater than K, clearly once we can find out that the A is now going to be greater than 2K minus K prime. Here what we will do, we will put it A being greater than 2K minus K prime, suppose we add K prime to it and then subtract both of them by 2. Nothing is going to happen, nothing is going to change as such, just the term will remain same. On the other hand, now if you compare the term which we had earlier, this one, yes, which was K prime plus K by 2. This term is always going to be greater than 2K minus K prime plus K by 2. Why? Because here what we have added to K prime is K prime. On the other hand, here we have added K to K prime. And we know that K is greater than K prime. Yes? So if we add a bigger number here, both the sides are being divided by 2 only. That means as the numerator becomes large, we will be subtracting larger number from 2K. So this term in that case is going to be greater than this term. If we plug in this here, so we get our result that A being greater than 2K minus K prime plus K by 2. This shows to us, and why we were trying to do that? Just to revise, we were trying to do this because this was the term which we were getting from the profit made by a competitor vis-a-vis a profit made by or the change in the profit enjoyed by the monopolist if he or she engages in innovation. So through this now we can very clearly show that the incentive, the motivation of a competitor of a competing firm is rather large as compared to that of a monopolist. Now we will come back to our other point where we are comparing the motive or the incentive to innovate of a monopolist vis-a-vis that of a competitor. Then we are adding a third dimension, and that dimension is of a social planner. Now the profit which will be enjoyed or rather gained by a competitor or a competing firm in a Bertrand competition is now equal to this area which I am marking by slanting lines. But what will happen from a social planner's point of view? If the price has fallen from K to K prime, ideally the price should also go down and additional quantities should now be supplied in the market. That would be the outcome of the perfect competition where the price charge will be equal to the marginal cost, and this marginal cost is now a new cost equal to K prime. In that case, we see that the quantity supplied increases in the market. And there is this triangle which we have that adds an additional dimension to the motivation that a social planner will have in order to, let us say, motivate or subsidize innovation. So from a social planner point of view, clearly the gains are much larger, and this additional gain, see earlier when we compared a monopolist competing firm in a perfect competition and then a social planner. So what are the reasons for the changes? What are the reasons for the the diversion in the result which we are getting? So from a monopolist point of view, we have understood the effect is because of the replacement effect. That means as the firm is now engaging into more process innovation, it's making profit, but this new profit or new made profit are also eating into its existing profit. So there is a replacement effect. On the other hand, competing firm has nothing to lose. So as a result, whatever they gain is the profit and the new profit. However, even when they will be doing that, they will not be charging the reduced price from the consumer, as they will have no motivation to do that. They will continue with the K, and result what will happen, the profit that they will make is now rather less. But from a social planner point of view, if the price fall, that means an additional unit are now being made available in the market. That additional unit is now available to consumer who were earlier do not have an access to this kind of a product because they were not able to purchase them. They were not able to buy them. As a result, this triangle is now adding an additional benefit to the social planner to support, incentivize, and to maybe subsidize innovation. So those were the points I have just highlighted. So here clearly, first from a monopolist point of view, you have to compare this green area with the pink area, which I have already pointed out with respect to the replacement effect. So green area is no longer available for the monopolist. That needs to be compared with the pink area. From a Bertrand point of view, this pink area which was there earlier, the other side L, now needs to be compared with this partly yellow and partly orange area, the rectangle that we have. And from the social planner point of view, this purple and the blue area now that has been added, and that makes us or provides us a comparison of the incentive to innovate in case of a monopoly vis-a-vis a competition vis-a-vis the social plan. One thing is very clear from this, that if you look at it, monopolist and Bertrand competitor then are going to undervalue innovation as compared to that of a social planner, and social planner has more incentive to innovate than both of them. Now the question arises that this entire analysis we have done on the basis of the non-drastic innovation, and what was the key characteristics of the non-drastic innovation was that if now with under the circumstance of a non-drastic innovation, the price which can be charged, let us say as a monopolist, is still going to be higher than the cost of production or the marginal cost which was there earlier. However, in case of a drastic innovation, it is going to change, and the monopolist price is now going to be A plus K prime by 2, which we have seen. Even Bertrand's competitor price is also going to be A plus K prime by 2. Why? Just to give you a brief recall, suppose we had a equation like this, and we have a cost here, let us say, and as a result, the firm will charge this price. Now this price is higher than the cost of marginal cost of production, K. On the other hand, if you have an innovation which brings down the price to K prime, now based on the marginal revenue being equated to marginal cost, the firm will decide how much output to produce. Once it decides how much output to produce, it will go with the price to be charged in the market depending upon the demand circumstance. And here you can see that the new price, that is P prime, is lower than the cost. So what does it change in the market? It changes in the market a situation, particularly from the Bertrand competitor, who can now act like a monopolist. With these new change circumstances where price has now fallen from K to K prime, they can simply charge P prime and drive out the other competitor from the market, because that competitor who doesn't have now access to this technology will not be able to produce and sell at a P prime. Again, it will give a position of a monopolist to the Bertrand competitor with the drastic innovation. Now we have seen in case of a non-drastic innovation, monopolist profit was eating into its existing profit. Whereas clearly, if the same circumstance arise with respect to drastic innovation, that also once again is eating into the existing profit of the monopolist. But from a Bertrand point of view, nothing such loss, nothing of that sort of a loss that happens. As a result, if you look at the profit equation for the monopolist would be under the K prime would be S into A minus K prime whole square by 4, and that of a Bertrand will also be the same. But when a monopolist has to choose, they will subtract this term. Why? Because that was the profit that the monopolist was making earlier. If so, then clearly Bertrand's competitor will once again have more motivation if he or she stands a chance of in fact becoming a monopolist with the extremely reduced price or coming up with a drastic innovation. So then this slides kind of explains the same thing. Earlier the firm under Bertrand duopoly was not making any supernormal profit, whereas the monopolist was making profit, which has now simply changed from this term to this term. As a result, the change in the profit for them will be this much, which is always going to be lower than this term, that is the profit enjoyed by the Bertrand competitor. So what do we have here? The major learnings from this entire exercise. First, there are going to be gains from the innovation, and those gains are going to increase with S. So where is this S coming into picture? If you look at in all the profit equation that we have got, S is in the numerator, right? So your profits are increasing with S, which we have defined earlier as a market size. Bigger the market size, more incentive, more gains are going to accrue to a monopolist or a Bertrand competitor as the market size increases. Clearly, the incentive to innovation will also be higher, larger, or the more radical innovation that we are talking about. The difference in terms of reduction in the marginal cost that has been envisaged through that particular innovation. Lastly, profit under Bertrand duopoly from innovation are going to be larger than that under the monopoly. Next, we will take extensive literature in this, and we will talk about the Indian case also.